Here we are, folks. We're at scatter plots part 2. So the first go around, we talked about just how to make them, and we looked at things like correlation. Today we're going to take it a step further. So in part 2, we're still going to look at correlations. Remember, correlation talks about how our two data sets relate to each other, hence that word inside correlation, relation, how the two data sets relate to each other. So does arm span affect height, that kind of thing. We're also going to talk about a few other ideas. So take a look. One idea is that when we get all these points on here, we can create what are called clusters, right? These are dense groups of data, all right? Not that we just happen to have a few points together, but they're very obvious, very noticeable. The data is clumping up. And so when we see that, that might make us ask a question. Well, why is the data doing that? Is there something we need to pay attention? Another item that we'll see, so to speak, are gaps, all right? This is where we seem to be either maybe missing data or simply where there is no data to be found. Again, if we get groupings of data, then oftentimes there are spaces between those groups that we'll call gaps. So either we might have data that's missing, maybe we didn't collect enough samples of a situation, or there just simply isn't data there. Or they're just simply, let's say we say missing data, or there just isn't data for a particular spot. And that might tell us something about our situation. And then there are outliers. And let's talk real quick about outliers. Outliers are points that don't follow the group's pattern. Now, it doesn't necessarily mean that you have a high spot or a low spot, that it's automatically an outlier. Outliers, when we talk about scatter plots, have to be points that don't follow the norm. All right, so real quick, let me show you an example. Let's say I've got a XY axis drawn here, and let's draw some points in, again, just to illustrate. So maybe our points are kind of in a linear fashion. They're heading up like this, right? So all those points seem to be following a positive linear correlation, right? Positive meaning that they're going up and to the right. Linear that they're following some imaginary line that they're all sticking pretty close to. If I had a data point, say, all the way up here, okay, that's not an outlier. All right, yeah, it is the highest point, but notice it's following that same basic pattern. So that would not be an outlier in this case. Where we could see an outlier, for example, is maybe down here. And again, just because it's a low spot doesn't make it an outlier. What makes it an outlier is that all the other points seem to be following this line, and then this one does not. So our red point, probably not an outlier. Is it a higher point than most? Sure. Is it an outlier? Absolutely not. Our blue point, is it as low as other points? Well, no, it seems to be right on the same level that these are, but that's not what makes it an outlier. What makes it an outlier is that it doesn't follow the trend, right? All of these are falling in line, and this one is not. So today, those are the other ideas that we're going to be looking at. Besides just making these and getting that practice in, we're going to be looking at, do we have correlation, whether positive or negative, linear or nonlinear? Remember, it could have no correlation. We talked about number of siblings and number of pets and discovered that, yeah, there is no correlation there. But we're also going to look at things like clusters, gaps, and outliers to see what can that tell us about our data set. So let's get started. The first data set we've got today is a little bit larger than what we saw before. And again, just to give us practice for graphing and whatnot, as well as creating our grid. So here's a blank grid. Let's get started. In this case, we're looking at prices on a used car lot. All right, and notice we've got two sets of information here. We've got the age of the car in years, and then we've got the asking price, so whatever the sticker price is on the car. So we'll see, does the number of years determine how that asking price is going to rise or fall? So let's graph it out here. So we can say age of car, and notice we're talking about years, right? Not months or decades, just straight up years. And then on the side here, we'll write asking price. And of course, in the US here, we're measuring in dollars. Cool, so we got that done up. And again, notice I am using a pencil, not a pen. This is gonna make life easy, especially if you make mistakes. So notice our years here are going up. Let's see, we got 1, 2, 3, and goes all the way up to 10. And I know that there are 10 spots here. I'm gonna count every 2 boxes and just do it 2, 4, 6, 8, just to kind of spread things out. Otherwise, you got to do 1, 2, 3, and that gets tiresome. So we got 2 years, 4 years, 6 years, 8 years, and then 10 years technically is right here, even though the line, for whatever reason, doesn't print out. And we're good with that. Cool, so there's the age. Let's look at price. The price varies kind of wildly here. It would seem to go from, say, 21,000, that seems to be the highest that I see, all the way down. Let's see, there's a 12. Let's see, we're still falling, all the way down to $4,000. So here's what I don't want to do. I don't want to start, for example, down here and go 100, 200, 300, 400. I wouldn't get anything to fit. All right, contrary-wise, I don't want to say 10,000, 20,000. All right, because then all of my data would sit under that line, and the rest of this would just be blank space. So I'm going to want to spread it out just a little bit here. So let's see. There's nothing under 4,000, so maybe we put a break in. And I'm going to start right at 4,000. That way our lowest point has somewhere to be. And then, I don't know, we got to go clear up past 20. So if we do 4, let's see, we'll kind of pencil this in at first. 8, so maybe every box counts for 2. So 4, 6, 8, 10, 12, 14, 16, 18, 20. Yeah, that seems to work great. And again, notice how I did that, folks. I didn't exactly write everything out. I just sort of penciled it in just to see what will work. And in this case, it seems to work just fine. So 4,000, 8,000, 12,000, 16,000. Got my commas. There we go. And then finally 20,000. And since we're only going up to 21,000, that first one will just go over 20,000, not 21,000. That 21,000, when we mark it, will just go over the edge there, and it's not going to be a big deal. All right, let's get graphing. So one of the cars on the lot is only a year old and is at 21,000, so we'll make a mark maybe about here. Another car on the lot is only a year and is at 16,000, so we'll make a mark there. Another car only 1 year and 18,000. Cool, so we got those done. 2 years, let's see. We've got a 2-year car that's also 21,000, so up here. Another car that's 2 years and 14,000. Another 2 that's only 13,000, so we'll put it kind of in between here, 14 and 12. 3-year-old car for 12,000. Another 3-year-old car for 14,000 would go about here, 14,500. I don't know, somewhere in there. All right, another 3-year-old car. My goodness, they've got a lot of those. Another 3-year-old car here for 11,000. So let's see, there's 8, there's 10, so 11 is going to be here. 3-year-old car for 10,000, so that's about here. 4-year-old car for 14,000, so it's up here. 4-year-old car for 11,000. 4-year-old car for 7,500, so that's down here somewhere. A 5-year-old car for 9,000, so that's 10, so 9 will go about here. A 6-year-old car for 20, oh goodness, I forgot, we had one all the way at 22, so yeah, it'll go up here a little bit, there we go. Maybe not quite that high, but that's all right. And then 10 we said was down here and at only 4,000. Cool. All right, well, let's take a look and see how we could read this graph and see what's going on here. So let's start with correlation. In this case, we definitely have negative correlation. Notice these points are pretty much trending downward with one notable exception. We'll talk about that one in a minute. So we could say definitely negative. Is it linear or nonlinear? All right, well, let's grab a piece of paper here quick, and let's see, because I've got a nice line going. Do our points seem to follow a line? And they seem to. It's not perfect, but they do seem to be wanting to go in a linear fashion. I'm not noticing too much of a curve here. Definitely a linear. This one might be perhaps an outlier. I'm not 100% certain. But yeah, I definitely could say a linear situation. So if we were talking about correlation, we could say that this has negative linear correlation. All right. Well, let's look at clusters. Do we see any groups that are really tightly packed? Well, we do seem to have this group maybe in here, but I'm not sure how much of a cluster that could be considered. If we had a lot more points in there, then sure, maybe, but potentially a cluster going on there, not 100% certain. Gaps. Well, we definitely have a gap, right? We've got a gap here between most of our cars being between 1 and 6 years of age, and then there's a pretty good sized gap down to here. Now, do we want to consider this a cluster and this a separate cluster? Well, maybe, but I would definitely say we've got a gap here. For some reason, most of the cars on the lot are between 1 to 6 years old, and then there's this oddball out here at 10 years. So something's different about that car other than just it's 10 years old. So maybe there's something going on there that we're not sure about. Let's talk about outliers. In other words, a point that doesn't seem to follow the pattern. Now, here's how I like to look at outliers. I try to take my finger and cover a point up, and if it drastically changes how things look, then it's probably an outlier. So for example, we said we weren't quite sure if this would be an outlier or not. So let me just cover it up. We still seem to have that negative nonlinear scenario going up with it there or with it not. So yeah, I would think that that one's probably not an outlier. Let's talk about this one. If I get rid of it, suddenly it's very obvious. Very much negative linear. This is an outlier. So if we're going to eyeball it and say, yep, there it is, we could say that we have an outlier at the point 6, 22,000. It does not seem to be long. There's something different about this data point. Now, does that mean we can erase it, get rid of it, pretend like it's not there? Absolutely not. You can never get rid of data like that. No, can't do it. It's very unethical. But we can make a note of it and say, look, we can maybe exclude it from some calculations so long as we make note that that's what we've done. But definitely we need to include it because there's something different about that car. Just like there appears to be something different about this car, though it does seem to follow the overall pattern. This one does not. So definite outlier here. So this is kind of the basic process that we're going to go through today, making sure we can make the graphs and that we can eyeball these ideas. What correlation do we have? What clusters, gaps, or outliers do we have? And does all of that make sense? And in this case, when we're talking about cars, yeah, the older the car gets, typically it loses its value. Obviously, there can be exceptions, but by and large, that tends to be what happens. So let's try another one. In this case, I grabbed some data from Babe Ruth's home run record hit. And what we've got is we've got the distance the ball traveled and how high that ball was above the ground at those distances. So let's graph it, see what we get, and ask some of those same questions. Is there correlation, clusters, gaps, outliers, that kind of thing? So on the x-axis, we have the distance traveled, in this case in feet. We've got the height above the ground for the y. And we're also measuring that in feet. Let's see here. On the x-axis, we go from 0, okay, all the way up to 570. So let's see here. If I made this 100, 200, 300, 400, and at 500, well, that doesn't seem to work very well because that'll leave that 570 off. Let's try, oh, I got an idea. Let's make it, instead of 100, let's make it 150. Then that would be 300. This would be 450. This would be 600. Yeah, that works a lot better because then we have somewhere for it to go, and it's still spread out fairly well. All right, that's fine. Let's see, going from top to bottom here, we're going to start at 3, go all the way up to somewhere in the, oh goodness, somewhere in the 140s, 150s. Wow, that's a big jump. Let's see here. Maybe we can do it. Maybe we can do it every, oh, I don't know. Let's see here. 50, maybe 50, 100, 150. Yeah, that would work. So let's see here. 50 for the first 3 boxes, 100 for the next 3 boxes, and then 1, 2, 3. Yep, 150 for the last 3 boxes. That looks good. Awesome. So we can fit everything where it needs to be. And notice, our scales don't necessarily match these numbers that well, so we are going to have to eyeball it, and that's okay. Again, we're just trying to get all the data on there so we can see it in a rough fashion. If you want them exact, type it into a computer in like a spreadsheet program and work from there. So at 0, 3, so this distance traveled, so I'm assuming the ball is about 3 foot off the ground when Babe hit it. So at 0, 3, I'm going to put that pretty much right here at the bottom. It's not exactly at 0, but it's darn close there. 3 feet above the ground, might as well be there for our scale. All right, so then we're at 100 feet, so that would be 75. 100's about in here, and we're at 83. So let's see, come up here, that would be about 75. So 83, I don't know, maybe in here somewhere. maybe in there somewhere. All right, we're at 200 now, so 200 would be just on the other side here, because this would be 150, 300, so somewhere in here, up to 130. I don't know. That's 25, so 30, I don't know, somewhere up in here. All right. At 300, we're right at 150 just about, so we'll put it there. I mean, it's ever so close. All right. At 400, so there's 450, so 400 is about here, is about 128. So that's going to be just a little bit lower than this point. I don't know. I'm going to put it about here. There we go. 500. So again, somewhere in this neck of the woods at 75. So I'm going to drop it just a little bit lower. If I can keep my hand still. There we go. Somewhere in there. And then at 570, so not quite to 600, it's at about 13, so that'd be 25, 13, I don't know, somewhere in here. Very good. Not perfect, but it's close. So let's go through it. What sort of correlation do we have? Well, I think it's kind of obvious. This data is following a pattern, but it is not a linear one. So definitely non-linear. Now, if we're going to talk about correlation, this is where things get a little weird. It's definitely nonlinear correlation, but is it positive or negative? Well, that depends on where you are on the graph. If we're on the left-hand side of my pencil, then it definitely has positive correlation. If we are on the right-hand side of my pencil, it definitely has negative correlation. So in this case, I'm going to leave that positive or negative bit sort of up in the air. No pun intended. It's just not going to make sense for what we're doing. Now, when you get into other levels of math, we'll talk about how this is and how we would describe a correlation perhaps a little bit better. But for now, we're just going to let it alone. We'll say nonlinear and leave it at that. Let's talk about clusters, gaps, or outliers. Any clusters? Well, not really. Our data is fairly uniform and spread out. Are there gaps? Not really. I mean, you can see that there's definitely a distance here, but there's pretty much distances between them all. Obviously, here in the lower ranges, they're a little bit further out because the ball's going very, very fast here. And then as it reaches the pinnacle of its travels, it slows down only to fall faster and faster again. But I'm not sure I would say that there are gaps. If we're talking about outliers, again, getting rid of any one of these points really doesn't change the overall shape of the graph. So I would definitely say that there are no outliers either. So no clusters, no gaps, no outliers, and in this case, definitely non-linear. All right, let's try another one. Here we go. I got some information from just random people. So we're going to call them patients for the time being. And we've got their ages, anywhere from 24 years of age all the way up to 63. And then I got their blood pressure. So again, all the way down here at roughly, let's see, smallest looks like 118, all the way up to, 165. That's a troubling one. But yeah, so let's take a look and see what we can find here. So I'm going to put probably a break in, my guess is, because we're not starting at young children, we're starting at young adults, so we'll probably need a break in here. So age of patients. And again, I'm going to assume that's in years, not in months. And then on the other side, their systolic blood pressure. And again, blood pressure in this case, systolic blood pressure, when your heart beats and that pressure is going through there, what it is. So not when your heart's at rest, but when, boom, it's beating. So let's see what we got here. 24 is our smallest, so I'm going to put a break in. And maybe we count, I don't know, 20, 30, 40, 50, 60. Yeah, that'll work, because our largest value is 63, and that would be somewhere in there, so that seems to work. So every 2 boxes for me counts for 10. Let's try for, oh goodness, yeah, we're definitely not going to start at 0 here. So let's put a break in. I'm going to start maybe at 110, and then go, let's see, 20, 30, 40, 50, 60. Let's see, what if we went 20, 40, 60? Yeah, let's do it that way. So 10, 120, 140, 160, and then 180. That gives us a little bit of gap there at the top. That's okay. All right, let's start plotting them. So I've got a 24-year-old at 118, so somewhere maybe in here. I've got a 25-year-old at 120 exactly, so right in there. I've got a 30-year-old at 122, so I don't know, maybe somewhere in here. 32-year-olds, a little bit older at 121, so just a touch down, but not much. I've got a 48-year-old, so we're going to take a jump here, and all the way up to 138. So I don't know, maybe that's somewhere in here. We've got a 50-year-old at 149, so almost 150. 57-year-old, close to 60 there at 120. 58-year-olds, again, almost at 60 at 154, so I don't know, maybe somewhere in there. And then a 63-year-old somewhere out here all the way up, goodness gracious, 165. They need to be careful there. They're kind of in a danger zone there. All right, so let's look at correlation. What sort of correlation do we have? Well, I would definitely say positive. It seems to be as our patients get older, their blood pressures tend to go up. So we could say positive. Now, is it linear or nonlinear? Well, I've got my paper here. This seems to be fairly linear. I mean, goodness gracious, we can almost predict it going like that. So yeah, positive, linear correlation. Cool. Not necessarily a good thing, but that is what it's showing us. Let's talk about clusters and gaps. Well, we definitely seem to have some clusters going on. We've got one group down here, we'll call them the younger group, in their 20s and 30s that seem to be, we're missing sort of that middle age, quasi-middle age range. And then we pick up again close to 50 and continue on up into the 60s. So definitely two clusters there. Gaps, yeah, we definitely have a gap in here. We're missing patients in those mid-30s to mid-upper 40s range. It's like those people just simply don't exist. So perhaps on this particular day, that just happened to be the people that came into the office, and that's who we saw. But again, not sure why we're missing data there, but surely there are people that age, and we could maybe guess what their blood pressures would be based on this. You know, a 40-year-old trying to get in line here with the data, maybe would expect their blood pressure to be around 130 or 140, somewhere in that neck of the woods. Let's talk about outliers. This is not an outlier. All right, notice it is the highest point, but that person's blood pressure relative to their age seems to be falling in line, right? This person down here, definitely not an outlier. While they are the youngest individual with the lowest blood pressure, they again are falling in line, so they're not an outlier. This person, however, seems to be a bit of an odd duck. Notice at 57 years of age, their blood pressure is way, way lower than their peers. Most of their peers are up here between 140 and 160, whereas this person's all the way down at 120. They're more in line with the 30 and 20 somethings. So this one, again, if I cover it up, notice, wow, super linear, super positive, definitely following a pattern. This one, obviously not. So we do have an outlier. And in this case, that individual we said was 57 years of age with a blood pressure of 120. You know, who knows, maybe that person's an athlete, maybe they're taking medication that's helping them with their blood pressure. Who knows? But there's definitely something odd about this individual. They don't seem to be following that same pattern. All right. One more thing before we leave. I grabbed this data off the internet just as something to look at, with lots and lots of data points that we didn't have to graph. These are looking at eruptions at the Old Faithful geyser out in Yellowstone. So here's the eruption time, so how long it took the eruption to go for. So anywhere from about a minute and a half all the way up to maybe a little over 5 minutes. And then wait times between eruptions. So maybe you had to wait 50 minutes or 80 minutes between eruptions, whatever. Let's look at this data. Do we have correlation? Well, yeah, definitely. It seems to be positive. The longer the eruption, the longer the wait time until the next one. That makes sense. If it's shooting more water out, it might take more time for that water then to build back up again. But we definitely have clusters. Look how tight this data is here at the top and here at the bottom, and there's very little in between. You know, we've got a couple of data points in there, but if we were to say get rid of them or just ignore them altogether, you can still see pretty serious clustering going on. In terms of a gap, not exactly. There are data points in there, but we could perhaps say that there's a small gap in here where only a few times it seems to happen. Other than that, it tends to be a lower eruption time with a lower wait time, or a longer eruption time with a longer wait time. And then let's talk about outliers. In this case, notice how other data that we had, like say our age of the car and price, tended to be linear, or in this case, age with blood pressure tend to be linear. And notice how close that they're following in line here. This line was drawn in for us here in orange. Yeah, the points seem to follow it, but some of them are a little high, some of them are a little low. So could we say it's linear? Yeah, it's linear, but not extremely linear. That's loose linear correlation. Whereas here, this is a definite linear correlation, again, based on the data. Positive and linear, but again, we'd have to start asking questions like, well, why does Old Faithful erupt in two rather distinct ways and not so much in the middle? What causes that? Just like we had here, we had questions. What happened to the 40-somethings? Why aren't they there at the doctor? It just so happens that there weren't any people there that day with that age. Maybe that doctor just doesn't have any patients in that age range. Who knows? But where we're going to go from here, now that we know how to graph and read, is start asking questions about, well, could we make a prediction? Let's say a 40-something walked in. Could we predict their blood pressure? Or, hey, what if we know the eruption time for the geyser was 3 minutes? Could we make an indication of how long we'll have to wait before the next eruption? And guys, that's where we're going. Being able to take this, create a linear function for it, and use that linear function to try to make predictions, whether it's predicting the future, predicting who that next person is that we're going to see and information about them, whatever it may be, but that's where we're going. All right, I look forward to seeing you in class. Y'all have a good day.